Oh, you're right. I was muted. Thanks for telling. So let me start over. So hello Twitch and hello YouTube. Welcome to another episode of RS Nano Live Coding. So yeah, let's see what we will do today, because I haven't prepared anything because today was a bit stressful and I just arrived home and I have not prepared nothing. So I think we're just going to pick up where we left last time, where we worked on making the unit test faster by using the nullable pattern from James Shore, and I think we will just continue there. And if it gets too boring, then we could switch to the bootstrapping code, where I also started to port a bit of code related to that, and we could just work on that. But yeah, today was an exciting day for Nano because there was a huge pump in the price. But it went. Let's have a look. Have you seen that, chat? Have you seen that? What the price today? It jumped up to 87 cents. And then it fell back down again. So that's crazy. From what I've heard, the SEC has filed a lawsuit against Binance, and it included a couple of cryptocurrency which the SEC sees as securities. And maybe that was the reason why the Nano price pumped, because Nano, there was no ICO. There were no coins sold. They were all just given away for free. And so Nano is not a security from my point of view. And ICO, thanks end of null. So maybe that was the reason why the price went up. Yeah, interesting times. Okay, so let's get started. So let's see. So we have the unit test, and I worked since last stream. I worked on moving or changing the unit test to use the nullable patterns. And if you remember last time, the tests, they took 10 to 20 seconds to run, and now it's already a lot faster. So let's just run the test. See, it is and I think the sounds are better now. I think the success sound. Let's run them again. You can hear the success sound now better now. Yeah. So they are faster, like already a lot faster. Like something like 2 seconds for 500 tests. And there's still potential to make them even faster. So what I did is, let's go to Visual Studio Code. So I have a lot of tests still that use the real LMDB implementation. And all of those tests, they use this helper struct that I created called ledger context. And what ledger context does is just make sure that the LMDB file gets deleted after the test finishes. So if we just here, this is the ledger context. So if we just have a look for the callers of ledger context empty, we get a list of all tests that, let me do that again. We get a list of all tests that still use the real LMDB implementation. And currently the number is 108. So 108 references. So 108 tests roughly that still use the real LMDB implementation. And last week it was like 270 something, I think. So I brought that down a lot already. And we can see it in the test speed. Like, really happy about that now. Even though I'm streaming and without OBS running, it's a lot faster still even. So it's maybe just 1 second without running OBS. And I love tests that run so quickly so much because it enables real test-driven development, where we write a bit of test code and then write a bit of production code, and we can switch between tests and production code quickly, and we get that feedback all of the time. Yeah. So, but before I start coding, I have not prepared any questions for today for the giveaway. So there will be a 5 Nano giveaway again. So I think we should just do it like I did in the first streams, where you guys just post your Nano address, and then we pick winners by random, by a random number. What do you guys think? Chat, what do you think? Jimbo says amazing. Yeah, fast tests. I get so excited about stuff like that, and maybe I spend too much time optimizing that, but I think it's important. I think tests should be really, really, really fast. Otherwise, they are just, a pain. Empty memories. Hello, welcome. Okay, so chat, post your Nano addresses, and then you will partake in the giveaway. Andefnal says, I have a question for the audience. I can't read that. Why is the X in Nano ticker? Oh, that's a good question. Okay, Andefnal. So the first correct answer to Andefnal's question gets 1 Nano. Jimbo, yes, you're inspiring me to speed up tests in my project now. Yeah, I think it's worth it investing time in that, because so when I was younger, I always thought that test code it's not important for test code to be good. I always thought test code was like a second, an important part. And I think I was wrong. I think test code is just as important as production code, and we should take care of it in the same way. Okay, we have our first Nano address from Sammy D. Empty memories, this looks good. Okay, so let me just copy Sammy's Nano address. So let me repeat. So the first one who answers Andefnal's question correctly gets 1 Nano. And the question is, why is the X in the Nano ticker? XNO. XNO. Why is Nano's ticker XNO? LF, good evening. Hey, welcome back. It's nice to see all those the names from the last stream again. Why is the ticker symbol XNO? Why does it start with an X? Answer that in chat and you get 1 Nano. But still we are going to do like a random giveaway, so just post your Nano addresses in chat. And so let me just create a file here with the Nano addresses, and this is Sammy D. Senorita, hello teacher. Teacher. Oh wow, I never thought, was never called a teacher before. Oh, Sammy D, it's not a country's currency, so it begins with an X. That's correct, Sammy D. That's the correct answer. Oh, I have a new follower. Senorita, hey, thanks. Great. Yeah, that's the correct answer, Sammy. So let me send you the 1 Nano. LFLF XNO because it is the international standard for such countries. Yeah, that's right, but Sammy was faster. Empty memories. Yeah, so let me just send you the 1 Nano. I have an alt here. So let's unlock the account and let's send you, Sammy, let's send you the Nano. 1 Nano. Send. Good, you should have it now. And you should have it under 1 second, because that's how fast Nano is, like half a second on average. Yeah, you got it, good. Okay, so the the others in chat, if you want to partake, just post your Nano addresses and we will keep them in a list here, and then we will just pick a winners by random chance. Okay. So let's see, where did I stop? I haven't worked on RS Nano today because I was at one of my clients. So I have to get into the Nano mindset again. Let's see. I think the last thing I did was working with block validation, especially Epoch blocks. Senorita teacher, can you give me one Nano as well, please? In my country, $euro is too expensive. You know what? Yeah. Send your Nano address and you get one. Oh, there we have another one. Let's copy that here. This is Newish Sitaula, if I can pronounce it correctly. Okay. Yeah, so I was working with block validation, and maybe there's even a diagram for how block validation works in RS Nano on GitHub. I'm not sure. Let's have a look. Okay, there's the Rust folder, and then we have Node, and then we have source. Is it in block processing? No. Where was that? Voting, cementation, bootstrap. Or was it in Ledger? I think it was in Ledger. Ledger source. Undefnal says, I've decided I'm not going to play today. I have another easy question prepared. LFLF. Are there any issues one can help you with in RS Nano? I couldn't yet get the project to compile, but wanted to try again at the end of the week. Yeah, so I think the simplest thing you could do is maybe just run a node. And if you run into any problems, tell me. I would propose on the beta network, because RS Nano is not tested like the official Nano node. So I run a node on the beta network and it works well. But if you guys want to help with testing it, maybe just bootstrap an RS Nano node and tell me if everything went fine. And if you want to help with porting it, yeah, it is difficult, because I ported all of the simple stuff already, and what's left is not so easy anymore. So it takes a bit of time to get into it now. So yeah, but if you really want to help, just get in touch on Discord maybe, and we maybe can figure something out. Like Fiona, for example, he helped a lot. We ported a couple of classes. Senorita teacher, it wants $10 at minimum to withdraw. What wants $10 at minimum? What do you mean? Empty memories, and to think that the life appeared to me out of nowhere. What a coincidence. Oh, did it? Okay. But you are from the Nano community, yeah? So Empty Memories says, it seems that I'm saying nonsense things, lol. Okay, chat. Yeah, get up. So here are the Ledger module, and the Ledger validates blocks before we insert them into the Ledger. And I refactored that in the past, and we have a diagram. So I tried to draw simple diagrams that explain how it works in RS Nano, because yeah, just for me and for people who want to help, I think this makes it a lot easier to understand what's going on. LFLF says, we'll hit you up on Discord then when I've got my PC back up and running. Yeah, great. Then I can help you with getting it to compile. And yeah, so maybe one thing that people could help is porting unit tests, because I ported a lot of production code and left the unit tests on the C++ side. But those unit tests, they should be ported to Rust too. And well, but at the same time, I usually just rewrite the unit tests to be real unit tests, and that means to not start the full node, but to just test a small portion of the system in isolation. Well, not really in isolation, but just to test, to have more focused, more narrow tests that run quickly, and where when they fail, we should know what's wrong. Yeah. So yeah, I've been working with the block insertion stuff, and as you can see in this diagram, it works like this. So there is the block validator factory, which creates the block validator, and this is the block validator is the main part. So the block validator gets one block. So you can see this here with the dependency to block enum, which is a block currently in RS Nano, and it does all kinds of checks with these blocks, all of the same checks that the official node does. Like, for example, if the signature is valid, if the balance, the account balance is correct, and stuff like that. And then it just returns the block insert instructions. And the block insert instructions is a data structure containing all of the things that need to change in the database if we insert this block. And I did this way just for a very hard split between logic and infrastructure code. And with infrastructure code, I mean the same thing as James Shore means. Infrastructure code is code that works with the outside world, for example. So with the database in this case. So everything that touches external stuff like network, database, the system clock, files is infrastructure. And so I made a split here. So all of the logic, which does the validation if a block is correct, is in the logic part. And the logic part just returns a simple instructions of what needs to change in the database. And the block inserter on the infrastructure side just executes those instructions. And that makes the block inserter really dumb and easy to test. There's not much logic in there. It just does inserts and updates. And we can test all of the logic without having to use a database, which makes the tests a lot simpler to write and also a lot faster. So yeah, so that's what I was working with the tests, because the unit tests, I ported the unit tests from C++, and they used the real ledger. And now I'm in the process of rewriting them to not use the real ledger, but actually so that the logic tests would only use the block validator and no database at all. So that makes the test also like a lot simpler and a lot faster. Yeah, so that's what I was doing last week. And I think we will just continue here. And for a while, for a bit. And if it is too boring, then we will have a look at, I think at the bootstrapping part of Nano. And maybe we can port a bit of the bootstrapping code then. Ready? Oh, and remember to post your Nano address if you want to partake in the giveaway. Okay. And before we start, we do the first giveaway. And it's only 2 in the list. So you have a 50% chance to get 1 Nano. So it's either Sami or Niyush Sitaula. Okay. Give you a couple of more seconds. Maybe someone wants to post their address. Oh, come on, Definitely, I'll post your address. So let's go to Google and let's create a random number. Between, okay, yeah, okay, thanks, Definitely. Between 1 and 3, because then we have three people. And Definitely. It's this one. Oh, empty memories. Until now, I'm seeing that in the corner, the chat appears here. Yeah, because this is the chat window here, and I wanted to place it behind the side panel, but it's too wide, and I can't make it shorter. So if I move it all of the way here, I can't read the full chat. This is details I need to figure out. Yeah. Okay, let's create a random number between 1 and 3. And if you hear it, can you hear it? I chose different type of music for the stream. Let me hear what you think about that one. Oh, LF posted his address. Let's include him too. Okay. Empty memory says it seems that I'm blind. What? Oh, Jimbo post. Oh wow! Now the addresses come in. Okay, let's add them all. This was the address of LF, and we have Jimbo. Okay, Jimbo. Okay. 1, 2, 3, 4, 5. So let's pick a number between 1 and 5. Between 1 and 5. Are you ready, chat? Okay, let's click the button. Yeah, so the random number generated is 5. So, congratulations to Jimbo. Let's get you 1 nano. Here, 1 nano. Yoo-hoo! Anderson, hey, well, I know it's the light, yeah. Okay. So, yeah, so let's get back to received. Yeah, that's how fast Nano is. Okay, let's get to the Epoch stuff. So, I have the tests here in Ledger tests, Epoch. Yeah, so there are 2. Yeah, this is maybe still interesting because it shows a bit about the history of Nano. So there are currently 2 Epoch blocks, and Epoch blocks are blocks that mark the beginning of new rules. And in the history of Nano, we had 2 Epoch blocks, the V1 and the V2. And now I would love to tell you exactly which rules they changed, but I haven't looked that up, and I don't know that by heart. But yeah, it has to do with the blocks, because in the beginning of Nano there were different block types. So there were let's create a new file here. Yeah, so there were these block types. There were open block, which opened an account. Then there was send, which would send. Why does it change? It would send Nano. Then there was a corresponding receive block, which would receive the Nano. And a change block, which would change the representative. And that was in the first years, or I don't know even how long it was like that. And then the Nano team decided to introduce a new block type, which is called a state block. And it would just combine all of these four different block types just into one block type to simplify things. So you could use a state block to send, you could use a state block to receive, or to change your representative, and you could even do this at the same time. You could send some money, and you at the same time could change your representative. And I think the first Epoch block disabled all of these old block types, which means they were not valid anymore. And the way it was done is the Epoch block was appended to each account on the ledger. So this had to be done that way because of the asynchrony of Nano itself. So every account on the blockchain had to be updated, and every account on the blockchain received an Epoch v1 block. And then there was the Epoch v2 block, and I don't currently know what this one changed. Does anyone know? Chat, do you know? What was the Epoch v2? Let's have a look at the tests. Maybe the tests tell us. What does Epoch v2 change? Maybe Epoch v2 was a change in the difficulty for the proof of work. And receive after Epoch v2. Yeah, so from the tests, I can't tell you why there was the Epoch v2 upgrade. So I think maybe it just had to do something with the difficulty of the proof of work. And there's another mechanism that Nano uses for upgrading rules, and that is the canary block. And the canary block is a special type of block that just gets pushed to one account, one special account, you could say, and the nodes, they watch this special account, and if this special block appears on this special account, then they know that the new rules should be activated. So these are the two mechanisms Nano uses for upgrades: Epoch blocks and canary blocks. Okay, so let's go to Epoch v1. And let's see, so these are rollback tests. Empty Memory says, until now I'm wondering what you do. What do you mean with what I do? Like what this project is about? Or Empty Memory is my Wi-Fi went off for a microsecond. Amazing. Yeah, so I work on Ars Nano. So I port the Nano node to Rust. And been doing that for 2 years now. And we're making steady progress, as you can see here. So roughly 36% is ported to Rust already. Sammy D says, I love the stream. I learned so much about Nano. Oh, that's great. That's what I was hoping, that people would learn stuff, because I'm still learning about Nano. So I'm far from knowing everything about Nano. Like I learn something new about Nano every day. And when I started, I did not even know I should have read the documentation when I started, but I didn't. And I didn't even know that there was, this change of blocks, where I thought, where in the beginning there was open send receive change, and now there's only state. And you can see this even on Nano Looker. So if you go to Nano Looker, sorry, and you have a look at a random block. Let's wait for a block. Oh, come on. Yeah, there's one. So if we have a look at the block, it says type state. Oh, let's make it bigger. So the block is a state block, and a state block has the account, a link to the previous block, the representative for this account, which can be changed by just setting a new representative into this field, the current balance, and the link. And the link is, in case this is a receive block, or a state block with a subtype receive, the link is the block hash from the send block, from the corresponding send block. And if this is a state block with the subtype send, then this link is the account number where we want to send to. That's why the link is represented as in this format here, and it's also represented as a Nano account, which is the same data, just a different representation. Yeah, and of course signature, that's clear, and proof of work that Nano currently still uses, and maybe proof of work won't be there at some point in the future, because now we have this awesome bucket system which prioritizes transactions, and in the past proof of work was transactions were prioritized by their proof of work, and that's not how it currently works anymore. Okay, so what's new in chat? I didn't know about all the different block types, Sammy D says, yeah. And if Null says, Epoch v2 blocks introduced increased work difficulty from what I'm reading. Okay, yeah, okay. That's what was my suspicion. Yeah, so Epoch v2 did not change anything on the blocks. It just changed the proof of work requirements. Empty Memory says, what exactly is the program project about? Until now I ask myself the question. So yeah, so I want to have an alternative node implementation for the Nano currency. And I want this alternative implementation to be in Rust. I want it to be memory safe and super fast. And I want it to have better unit tests. So like really, really fast tests and decoupling in the system itself. LFLF says, in what version will proof of work will deprecate it? I don't know. There is no plan currently, I think, but because it is still helping in preventing spam or handling spam. I think it's still playing a role in there, but it's not the primary mitigation against spam anymore. So this bucket system we have now is the thing we use, to handle spam, and it's a lot better. So a really great idea. I don't know who came up with this idea, but it's a great idea. Yeah, so let's go to the project. Okay, so Epoch v1 tests. So these are the tests that use the LMDB database. And so there's a test. So there are also tests in there that test the rollback, because there are certain scenarios where we have to roll back a block. And there's also tests for rolling back the block, but I have not ported any rollback tests yet. So let me just quickly have a look at how that works. Oh, there's a rollback performer. Okay. I think rollback is the same structure as validation. Maybe I even created a diagram for that. Let's see. Do I have a rollback diagram? Yeah, I did. Great. So yeah, it's the exact same structure. So there's the rollback planner, which does all of the logic without accessing the database. It just gets all the data passed in with a data structure, and it returns the rollback instructions, which contains everything that needs to be done to the database. And the rollback instructions executor just executes those instructions, just simple update statements in here, no logic in here, and all of the logic is in the logic modules. And so here we have to do the same thing. We have to write the tests by just using the rollback planner, and that will make the tests a lot faster. So let's see if we can if we can port this rollback test here. So what? Oh, sorry. This is the test. Rollback epoch. Let's create a new file at the correct location. So because right now all of these tests are in the ledger tests folder, but because we now use the rollback planner directly, I want to have those tests at here in the right folder, which is block rollback. So, and because there are a lot of tests, these tests are in the same file as the production code, but because there are a lot of tests for rollback and block validation, I just create a subfolder here. A new subfolder, and I call this tests, and then I split them up into the area they are testing. So let's add this module tests here. And oh yeah, and of course we only want to include this module if we are running the unit tests. So CFG test thing here, so that will include the tests module only when we run the unit tests. So let's add our Epoch V1 rollback. So let's add a new file here, and we call this rollback Epoch V1. And now we can place all of our rollback tests for Epoch V1 into this file. Okay. So let's copy this test. And let's paste it here. And now how can we change this test? So it uses the ledger context, and we don't want that. So let me just comment everything out. And we want to start with the rollback planner. Rollback planner. And that's how do we construct this? Let's see. Okay, as you can see here, this is all the data that the rollback planner needs for planning the rollback. So it is the epochs, which is information about the epoch blocks, like who is the signer, and who's the epoch account, the head block from the current block, the account from the current block, current account info, previous representative, the previous block if there is one, the linked account. I think this is the account that if our block has a link and the link is for an account. Pending receive. Yeah, there's a lot of information required if we do a rollback. And so this is the rollback planner, and here it does its thing, and it returns the instructions at the end. So these are the rollback instructions, and for example, the old account info is how the account info was, or the old one, and the set account info contains the account info that the instruction executor should write to the database. And for example, the remove pending means that the instruction executor should remove the pending entry that this contains. Yeah, so I think this is simple or easy to understand what it does. It's just a lot of data, but that's just part of it. So we can just write our tests against those instructions. And we create our planner by providing it with these data. So let's add all of that. And in the production code, the rollback instructions executor is the one who writes it, and the rollback performer calls the rollback planner factory, and the rollback planner factory is just loading all of that data from the ledger. And we don't want to, because then we would, in our tests, because then we would have to set up the ledger to return all of that data, and that is just complex. And I don't want to do that. So I just want to give the data directly to the rollback planner, and that simplifies the tests. So there's new messages in chat. Let's see. Empty Memory says, I have to go, bye, take care. Oh, bye, Empty Memories. LFLF says, can you post your Nano address for donations? Yeah, sure. So the simplest way to donate to the project is if you go to Nano. Oh, I can point up there. If you go to nano.2/Gustav, because that is, let me go there, nano.2/Gustav, and this brings up this page, and this QR code is my donation address, and the same address is also on the Ars Nano website. So on the Ars Nano website, if you scroll down a bit, there it is. It's the same address. Okay. Okay, so Epoch. So we have a rollback planner, and we need some epochs here, and epochs is of type epochs, and I think we can just use this. I have stub ledger constants that we can use. Yeah, epochs. Head block account, current account info, previous representative. So, do we need all of that data? Let me just fill it with random stuff. So let's create random stuff. So like block hash from 1 account, this account from 2. Current account info is account info, so let's create just test data, account info. Oh, didn't want to do that. Current account info. Do we need this data here? Previous representative. Yeah, no, I think not in this test. Account from 3. Current account info. Why do we need the current account info? Add representative own block. Oh, there's a lot of stuff in here. Why do we need... This makes me think, why do we have the head block twice? We have the head block here, and we have it in the current account info. That makes no sense. Maybe we can optimize this a bit. Let's use the same one here, and then maybe we can simplify this test later. So representative. Let's create... Where are we? 5, 6... Open block. Is this all required? Balance. Let's create balance. 100 raw. Modified. I don't think we need that. Block count. Epoch. So the epoch, this is the thing we are testing here. So, and don't worry, we are going to get rid of all of that nonsense data here, because I like to hide everything that is not relevant for the test to make this test readable. Because right now, this test, you would not know if you were new into the project and you would look at it, you would say, oh my god, so much is going on here. And actually only one thing is relevant, which probably is this line here, the epoch. So we will try to hide all of the irrelevant information. So so let's say epoch, this is epoch This is rolling back epoch v1. So let's say this is an epoch v1 account. Previous representative is what is previous? Is this the block? An option block, you know. Do we need this? I think we do. And what block should the previous one be? Let's make the previous block. Yeah, why? I'm not. Just, I think also state block is valid. It doesn't matter actually. Linked account. I don't think we need a linked account. Public key. Let's make the linked account 0. Pending receive. Is this an option? Yeah, so we don't need a pending receive. Latest block for destination. Do we need that? No, also an option. None. And confirmation height is confirmation height info. There we have a height and a frontier. Let's just make that frontier the same as the head block hash from 1. So, okay, let's include all of the things we're missing. Block hash and account and amount. Account and amount. No. Yeah. Amount. Count. What's wrong here? Oh, it expects head block. Oh, it doesn't expect a block hash, it needs a block. Why? Let's create one. Just random data. Let's just slowly find our way to running a green test. And what about the previous representative? Oh, it is an option public key. I don't think this is required for this test. So let's make it none. Okay, so we got a rollback planner with dummy data. And now how can we call this planner? Let's see, what does it have? It has a function called rollback head block. Yeah, that's it. Yeah, because the head block is the latest block for this account. And we only want to roll back the head block. And if we want to roll back more than one block, we just keep calling rollback head block. And rollback head block returns a result of rollback step. And the original test, it did the rollback, and then it just checked that account info was back at epoch 0. And we are going to assert the same. So let's unwrap this or expect this and say rollback should succeed. And in the result we have, what do we have in the result? Rollback step. Oh, it's an enum. Ah, yeah, I remember. Yeah. Because there are dependencies. So if we, for example, let's say we want to roll back a send block and the send block was received already, we have to roll back the receive first and then we can roll back our send block. So that's why it returns a rollback step, which is either a direct rollback with rollback block here, Or it says we can't roll back these blocks yet. We have to do some other rollbacks first. And that is the second option here. It says request dependency rollback. And it just this contains the block hash that we should roll back first. And that block hash could also return request dependency rollback. And so this could iterate many times. And it would lead to the rollback being done in the correct order, because we can't roll back a send block if it was received. So we have to roll back the receive first. So yeah, that's what. So I'm expecting this to. So what does it return? A result? Okay, so I'm expecting this result to be of type. What was it called? Let's close those files I don't need. I'm expecting this to be a rollback step of type rollback block. So let's say let instructions, let rollback step, rollback block instructions. This is the new, oh, it's not so new anymore, but it's also, it's quite new. The let else syntax, which I like very much. So we can say let rollback instructions equal to result, and then we can say else. So that means, so if it is a rollback block, we get the instructions here, and if it is not, we go to the else branch, and here we can just panic and say expected, yeah, rollback block, but it wasn't. Okay, and then we want to assert that our instructions contain the new account info with epoch being equal to epoch 0. Oh, and we have to write tests for the instruction executor too. Yeah. And this test will certainly not pass, because all of that data is just garbage. And now we have to find out what is the correct data. So let's run the tests and see. And if null says, wow, that is some weird syntax, result else panic. Yeah. Yeah, but yeah, it's new, or kind of new. It was introduced, I don't know, a couple of months ago, I think. Oh, where's the test? Here's the test. Oh, now they are slower again. Strange. Okay, so that we have one failing test. And the test panicked at... Oh, rollback planner panicked at line 72. Oh, there was no sideband in the head block. Yeah, okay, no, that has... The head block needs a sideband, that's for sure. Can we move this out of here into a variable? And we call this head block. So, yeah, the head block needs a sideband. That's true. So, in case you're wondering what a sideband is, so the blocks, they don't contain all of the information that we need. For example, it does not contain the account height, which means the number of blocks in that account. And all of that data is stored in a so-called sideband, and that is just stored in the database with the block. So let's set the sideband to... I wanted to change this design, by the way, but I can only change this design once everything that uses blocks is ported to Rust. Because currently a block can have a sideband or it can not have a sideband. And that's just confusing in the code, because I do have to use unwrap a lot when I access the sideband, even if I know that if a block comes from the database, it always has a sideband. That's a rule. So there's no way a block would come from the database without a sideband. And so I want to introduce two types. I want to call one the unsaved or the unsaved block, or just block, which does not have a sideband. And the other type I want to call a saved block or persistent block or something like that. And this would always have a sideband, and then I would not have to unwrap that sideband all the time, and it would simplify the code. Jimbo says, reminds me of Python conditional assignment. Looks something similar, I believe. Oh, okay, cool. I don't know Python, so yeah. Yeah, so let's set the sideband to BlockSideband. Let's see what the sideband has. Yeah, as you can see, the sideband contains the height of the account or of this block in the account chain, the timestamp when it was added, the successor block, so the next block in the chain, if there is one, the account, the balance, the details, and the source epoch if it was a receive block, I think. And maybe all of that data is not required, so let's just see if we can get away with just some random data. Create test instance. Let's get back to James Shore's article, which I recommended in the last stream, and I'm recommending it again in this stream. So let's just go to his website. This is James Shore, Agile coach, and streamer, and he has some awesome ideas about unit tests. And he has this article called Testing Without Mocks, a Pattern Language. It's pretty new, and I'm a huge fan of it. And he describes his system of writing unit tests that are really, really fast, and they don't use mocks. And they test the actual production code with all of the benefits that a mock would bring. And he recommended this to have a function like create test instance in our production code, which would just create the thing with some dummy data. And I like this because I don't care if I have test code in the production code. And this is just a very easy way to just create an instance here where we don't care about the actual values. And this makes our tests just easier to read. So let me see what's new in chat. Andefnal says, what data can be in a BlockSideband? Okay, let me open that again. So, as you see here, the height, which is the block height, so the height of this account in the account chain, and yeah, timestamps, successor block, the current balance. So some of this stuff is not needed anymore with the state blocks, which contain a lot of information. But as you saw in the beginning, there were these other block types like open, receive, send, and they would not have, for example, they would not have the account in it, or they would not have the balance. And so, especially for the old block types, the sideband is really important. So, Andefnal, oh, you posted the article link. Great, thanks, man. LFLF. There's also a project called Dagchat that includes memos and messages stored on the Nano blockchain. Yeah, and I think... do you know how it stores the messages? Does it use the representative field for that? Dagchat. I've heard of Dagchat, but I have never looked into it. Do you know how it works? On-chain memos. Because there's no way, and this is great, like Colin did a really good job of thinking about what should be in Nano and what shouldn't be in Nano. And he did not include a memo field, and this is a topic that is discussed very often and emotionally. And I'm fully behind Colin's decision to not include a memo field in the blockchain, because this just opens the doors for other attack vectors, let's say, like we see in Bitcoin with all of these. What is the name where the blockchain is used or misused to store pictures of, you know what, like NFTs. LFLF says maybe it wasn't Dagchat. I'm looking it up again. And Defnal says yes, I know it's by design. Yeah, and so Colin decided not to have a memo field in Nano, and this just makes Nano robust against this. I think Colin called it parasitic data, and that's a cool name, because we see this in other cryptocurrency projects right now where the blockchains are misused or not used as they were intended to, just because there's a way to add arbitrary data to it. And in Nano, it is currently still possible to add data to it by misusing the representative field to store data in there. But I think in the future this will be fixed, so that you can only set a representative to an existing account, an opened account, and that would prevent storing arbitrary data by using the representative field. You could still store data by using the amount field, but that would cost money then. And I think, I think that design is really good. And Defsnal says, lol, metadata parasites, yeah, I mean, like, I think you saw how the Bitcoin transaction fees went through the sky after this. What was the name? What was the name of this project that embedded NFTs into Bitcoin? Do you know, chat? I don't know. So that is BlockSideband here. Jimbo says Bitstamps something. Bitstamps. Stacks? Was it Stacks? No, it wasn't Stacks. What was the name? I used to be a huge Bitcoin fan, by the way. So I encountered Bitcoin pretty early, and I found it to be revolutionary. And I thought this is going to change. This will change everything. And I was a huge fan of Bitcoin for years. But then I grew more and more skeptic about the scalability and about the energy consumption. And then I encountered Nano and everything changed, and I left Bitcoin behind. I switched all of my focus to Nano, and now I'm not up to date with what's going on in Bitcoin really. I read stuff on Reddit from time to time, but I'm not my focus is on Nano now, because I think Bitcoin is just it's just hopeless really. Like, there's so many mistakes in the design of the protocol that can't be fixed easily, that can't be fixed with a hard fork, without a hard fork. So yeah, that's why you don't ask me questions about Bitcoin. LFLF says I can't post links. Dagchat uses the misuse of representatives you mentioned to store memos and chats on Nano. It was explained on Reddit. Yeah. Okay. Yeah. Yeah. So that is currently possible to use the representative field to store data on Nano. But yeah, this will be changed, I think, in the future, if it really becomes a problem, because currently it isn't. But this can be fixed, just by making sure that a representative has to exist if you want to, change your rep. So we haven't written much code yet. I've been streaming for 1 hour, and this is all we've written so far. Okay, so let's see. So the test failed because there was no sideband. So now we added a sideband to the head block, and let's see. if the test fails for a different reason now. Strange that the tests are slower now. So there's another unwrap in the rollback planner, line 180. Let's just close all of those tests. What is this? Epoch v1. This is the test we were working with. Just want to close some files here. These are the rules. Let's keep them open. Let's close that, and let's close the block store. Okay. So what was it? Line 180. The previous block doesn't have a sideband. Okay, so the previous block has to be Epoch 0 if we roll back an Epoch block. So where's the previous block? Here. So let's introduce a variable for the previous block. And this has to have a sideband too. And in this sideband, this has to be Epoch 0. So we say, oh, it only has a source epoch? Wait a second, let's go to the rollback planner again. Previous epoch. Details. Oh, it's in the details. Oh, okay. So this has to have details. And this is block details. Block details. And here we say the previous block is Epoch 0. And the previous block is, it doesn't matter what it is. It's a change block. So it's not a send, it's not a receive, it's not an epoch. It's not an epoch. And the other data, maybe we can just say use just random test data for the other fields. So that's a nice thing in Rust where you can just say dot dot and give another instance, and it would just fill in the other fields that we haven't specified yet with this test data here. Okay, but that means, what's wrong here? I cannot use a comma. Okay, let's remove the comma. That means our head block has to be Epoch 1 in the sideband maybe. So let's also do that, set that here. So let's say this head block gets a sideband, and we set the details to block details. So this is Epoch 1. And it is not a send block, it is not a receive block, but this one is an Epoch block. So I think this has to be true here. And let's see if we can just use the dummy data here for the other fields. So like that. And oh, this looks really ugly, but trust me, we will clean this up. Okay. Let's run the tests again. The tests are green. Okay, I'm confused. So that means all of the data we provided here is okay. So I think it won't get used. Cool. So we ported our first test, or we changed our first test to just test the rollback planner directly. Okay. I don't want to refactor or factor out of the irrelevant code yet, because there's more tests for the rollback, so I want to have a bit of duplication first usually, so I can better see which parts are irrelevant and which parts are relevant. So from my experience, if you extract methods or refactor too quickly, you have the tendency to get it wrong, and then you have to rework. So usually, I wait for duplication to happen. Like if I have 3 tests that look the same, then maybe I will start refactoring it and make it more readable. But usually, I think it's a good idea to let duplication occur and learn from it, and then to refactor. LF says, love the sound when the tests pass. Yeah, me too. These are open source sounds, by the way, and I've checked them into the repository. Yeah, they are on GitHub. Okay, so so that test is green. Maybe let's just do the same thing for another rollback test for Epoch blocks, and then we can make them more readable. So the next one would be, so we have rollback Epoch, and this is the one we just rewrote in a different style. So let's delete this. And now we have Epoch block with change representative fails. Oh, this is not a rollback test. Ah, okay, so there was some... Oh, maybe this was by mistake in here, because usually I have all of the rollback tests in a different file. Yeah, then let's leave the rollback test for tomorrow, the other ones, and let's focus on the next one, on this one. So what this test says is an Epoch block is not allowed to change the representative. And if it tried to change the representative, it should fail with this error code here, representative mismatch. So let's delete this here and go to our validation test for Epoch v1. And let's add it here. So what it does is it changes it tries to change the representative. And what we do is so this, yeah, let's take this test as a template. So what we do is we create an Epoch block. So we have an existing account with this open block that we create in this first line. And this account has old account info here. So it's just some account info for this account. Then we create the Epoch block for this account. And then we call validate. And we assert that result is equal to error with the error code representative mismatch. But we have to change our Epoch block first, because this is a valid Epoch block. And let's see how it is created here. Maybe we just return the builder. So so because we want to change the representative to something invalid, so let's not return the final block, but let's return the builder, state block builder. And then we can change the block. I probably have to adjust a couple of tests now. Create Epoch block. We have to say .build now in all of those tests that use this function. Here, and we're not. Oh, that was it. Just two tests. That's not much. Okay. So now we have this epoch block, and now let's set the representative to something invalid. Or yeah, just whatever. Doesn't matter really. It just has to be a different representative that we have in our account. So now we have this epoch block. Let's rename it to epoch with invalid rep. So it makes it really explicit what we're testing here. So this should now, or I want to see it fail first by asserting it is equal to, let's just say that signature, whatever. I want to make sure that this test is actually executed when we run our tests. Oh, we have to say build. Okay, so now it should, yeah, now it should be okay. So let's run this test now. And we have a failing test, and the test fails because, yeah, it returned with representative mismatch, which is the correct behavior. So let's change this expected value to representative mismatch, and this makes the test pass. And as you can see here, I already have helper methods in for these validation tests. Yeah, let's just make the tests go green. Oh, we can hear it in the sound. I have already helper methods here to hide all of the irrelevant stuff that we don't need to know for understanding the test. And we have to shrink our rollback tests in the same way, because here they are full of irrelevant stuff here. And once we have more rollback tests, I'm going to refactor them so that they are small and easier to understand, just like these tests here. Okay, so we have this test now running. So let's see what's the next one. The next test is, Chat, tell me, what do you think? So I thought this stream would be really boring working with all of those tests, but I think just by reading the tests, we learn a lot about Nano. Because let's take this test here. It says cannot use legacy open block after epoch 1. And this is what we talked about earlier, is after an epoch v1 block is in an account, or is this is about the sending account. So once the sending account got upgraded to epoch 1, we cannot receive from an epoch 0 account anymore, because we have to wait until our account is also at epoch v1. So this is what this test is about. So let's delete this here and let's insert it in our epoch validation file, the tests file. And let's write this in a different style by accessing the validator directly and by not using the ledger. Should we do another giveaway? LFLF says, the tests are really interesting, don't worry. Yeah, I think this is just by having a deeper look at the tests, we learn a lot about how Nano works internally. So maybe I should do this more often on stream. Let's do another giveaway, guys. So if anyone has joined and wants to participate in the giveaway, just post your Nano address in chat, and we pick one winner by random. So we have 1, 2, 3, 4, 5 people participating. And if Null says, I like how you rewrite these tests, it looks much cleaner. Yeah, because they are more focused. They use less of the system, and that makes them, yeah, more focused. And a lot faster, because now these tests, they don't touch anything infrastructure related. They just get their test data and directly. We just create it directly. And in the other tests, we have to set up the database to contain the test data. And that setup sometimes is difficult. And especially if you have a look at the Nano, the original unit tests in the original Nano project, it looks even more complex because of that test data setup. So yeah, so let's do it. Let's do another giveaway. So we have five people in here. Let's create a random number between 1 and 5. Ready? Let's push the button. So the random number is 4. That means LFLF, you get 1 nano. Copy. Like here, like 1 nano. Here we go. LFLF asks, where did you get the nano mug in your background from? Oh, I got it as a birthday present 2 years ago, or 1 or 2 years ago from my brother's wife. And I use it. I use it. Yeah. Was really happy about that gift. Chat, do you know these things? They are so delicious. Okay, so LF says thanks already there. Yeah, and if not says I hate those. Really, you hate those? How can you hate these things? They are addictive. So cannot use legacy open block after Epoch 1. Okay. So we have to, what does this test do? It has an Epoch upgrade, and then it does a send, and then it tries to receive that send with a legacy open. Let's see if we can recreate the same scenario here. So we have to use this helper function here first. We create create Epoch 1 previous block. So we have that. We have an Epoch 1 previous block, and then we create a send block. And then validate. Let's have a look at validate. We need pending receive info here. LF says, I can't stand toffees either. Toffees either. How is it pronounced in English? Toffees? LF. Oh, I see you're a man of culture also. Yeah. Okay, then more toffees for me. Okay, this function is too simple now. We have to make more changes to our block validator. We have to give it the pending receive info. Maybe we just... Let's move this one to a function. And we call this function create validator. And oh, this is a lifetime issue. A lifetime issue because of that. This is... Can we add the lifetimes here? I don't think this will work. And if we make this one also a reference... Oh, this works. No, it doesn't. There's... No, these tests. Does this work? Let me just compile quick and then run the tests and to see if this works. Yeah, cool. Okay, so we have the create validator and we can just use that one here in our test. So we say create validator. And what does create validator take? Previous. Previous is... Oh, there is no previous because our block is the first one. Our block is the open block. So the previous has to be an option. Or maybe we just don't include it here and say previous is none. And we set it here. Like that. And account. Oh, it took the account from the previous block. Then let's pass the account in here. It took the account from the previous. Okay. So, okay, now our create validator, it takes our block. So this would be legacy open, and oh, come on, open, and the next argument is the account. So let's take this from our legacy open block and the old account info, which is, oh no, the old account, there is no old account info because it's a new account. So this is also none. And here we set it, validator, old account info. Some old account info. So there is no old account info. So now we just create the validator like that. We just have to create the legacy open block. So let legacy open equal to block builder legacy open. Let's see. Maybe we need more data and we have to specify it here. But let's see what the test says. So we have the validator, we have the legacy block, and And now we have to, let's see, we have to set the pending receive info to pending info. So this now what I write here is when we open a new account, we can only open an account if there is a send to that account, a send block for this account that this new account can receive and open itself up. So the database stores all unreceived sends in the form of this struct here, pending info. So it contains a source account who did the send, and in our case that doesn't matter, so that's just created from 1, and it contains the amount that was sent, and in our case that also is not relevant. So 100 raw, and the epoch. And this is important now because let's say the sender was already on epoch 1, and something new in chat. LFLF says, how are new Nano addresses generated, by the way? And does anything happen in case of a collision, even if it is extremely unlikely? So Nano addresses are just 256 bits of random data. And so they are just generated with a secure random number generator. Or you could throw a coin for 256 times. And yeah, that's how they are created. And that doesn't sound very much like throwing a coin 256 times, but that gives you more possibilities than atoms in the universe, I think. And a collision is extremely unlikely. Like, it's so unlikely that there is there's no code that would handle a collision. But so if this is so unlikely, like there's even in Bitcoin does the same thing. It also has 256 bit keys, and there is this project called Large Bitcoin Collider, which just tries to create a collision, like tries to find private keys just by brute force, and the numbers are mind-boggling. So let's see how many hashes per second or how many keys they check. So here you can see they currently check 189 million keys per second. Like 189 million keys per second. And this project has been searching for years. This is an old project, and there is no way that they found a little bit. They found some keys, but they were not really random keys. They were keys in, let's say, in insecure places. Yeah. So there's no way will be a condition in Bitcoin or in Nano. Okay, so so pending info, yeah. We created the pending info for our send and received send, and then we create the legacy open block here, and that open block should receive that pending stuff here. And let's see what happens now when we call validator.validate. So let's call validator.validate, and it returns a result. And we assert that this result is oh, let's add the expect here. Oh no, it should not be. Yeah, so it should return an error, and the error should be error, and the errors should be unreceivable. So let's see what the tests say. Oh, there's an error in the code. Okay, amount isn't known. And LF says, cool projects, thanks for the insight. Yeah, you're welcome. Okay, it says the error was gap source and expected was unreceivable. So gap source means the source block wasn't found. So I think we still have to give that information to the validator. So the source, yeah, source blocks exists. We have to set this to true, because this is also a check that the validator does, that we can't receive a block that doesn't exist. Oh, looks good. The test passes. So let's delete that. And can we make this maybe more readable? So the source and the amount is not relevant for this test. Maybe we can just also use the dot default. No, let's use the test data. Do we have a pending info test data? Create test data? Yeah, test instance. Let's see if this also makes the test pass, because then it's a bit more precise about what it is testing or which data is required for testing. Yeah, green. That's why I like to play sounds if the tests pass, because then I don't have to look at the tests all of the time. So that test is good. Okay, and what else we got? Cannot use legacy receive block after Epoch v1 open. So this is basically almost the same. Here we test that. Here we test that if our account is on Epoch 1 and someone sends us no, we can, if our account is on Epoch 1, we cannot use a legacy receive block anymore. We have to use a state block to receive something. So let's rewrite this test, and the assert can stay. We reassert that it fails with block position error. If in this case, so we need cannot use legacy receive block after Epoch v1 open. So we need, let's see, what can we reuse here? We need a previous block, which is this one. We create Epoch v1 previous block. Then we create a validator. Let's use this create validator function. So we create a validator. takes the block that we want to validate, and that is the legacy receive and an account. So let's create the legacy receive. Legacy receive. And then we have to set the receive info again. And let's say the receive was, or the send, what happened on epoch 0. It shouldn't matter actually, but let's just set it to epoch 0 so that this test is clearly distinct from this test above here. So the send was epoch 0. What else do we have to set? The old account info in the previous block. Okay. Validator.old account info is old account info. And the previous block is previous. So if we call validate, then the result should be block position. Oh, it has to be mutable. Okay. Let's see what the tests say. Tests are green. That's not good. It's not good if the tests are green on the first try, because then I don't know if the test actually works. So let's just change our expectation to bad signature and see if it fails now. Yeah, it fails now. Okay. Let's go back to block position and let's remove all of that here. Yeah. Okay, next test. Next test is cannot use legacy receive block after sender upgraded to Epoch. Didn't we test this already? Let's see. Can it state blocks after V1? Block with changed fails. Cannot use legacy open. Cannot use legacy receive block after Epoch V1 open. No, this is actually a new test, yeah. So if the sender is Epoch 1, we cannot receive it with a legacy receive. Is that right? Legacy receive? Yeah. Okay. Let's rewrite that test here. Move it to here. And so the result should be unreceivable. And let's just use that here as a template. And so I'm not a fan of how these tests look here, because this is already, for my taste, too complex for a test. I like this test to be really, really small and simple to read. But I don't have an idea of how I could refactor it right now, so I'll let it be for now, and once I have a better idea, I will refactor it. So, cannot use legacy receive after sender upgraded to V1, Epoch 1. So we don't need an Epoch 1 previous block, but we need, what do we need? We need a a legacy previous block. Do we have a helper function for a legacy previous block? No. Then let's create this by hand. And let's refactor out a helper method later. Oh, create legacy. No, what this is? Create legacy change block. Create legacy change block with a previous? No. Okay. So let's do this all by hand. So let's create a key pair. Let's create the previous block, which is a legacy open block. And this has to have a sideband. Yeah, does it? Does it have to? Yeah, it has to have a sideband. Or does it use the account info? No, the sideband. So BlockSideband. We just care about the details. And we here in the block details we say it is Epoch 0. And it is a receive. No, it is not a send, it is a receive block because it is an open block. And it is not an epoch block. And the rest we just used our dummy data as a filler. We have a question from LFLF. What is a sideband again? Oh, it's just metadata. Metadata for a block. So, because there's not all of the data in a block that we need, for example, the block height. The block height means its position in the blockchain. And it also contains the current epoch for this account. So, by setting the sideband for this block, we say epoch 0. And that means that this block was created at epoch 0 and follows the epoch 0 rules. And so this is what this test does now. We test that our account or our receiving account is epoch 0, and someone sends money to us, and that sender is already on epoch 1. What this test tests is that we cannot receive that money until our own account is also at epoch 1. And this is what this test does. So we set the sideband for our open block to epoch 0. And then we create our legacy receive. Let's call this legacy receive. And our legacy receive it is there to receive this block. Or to receive this money, but LF says makes sense. Thanks. Yeah. Keep here previous old account info. Legacy receive. So this is the receive block we want to test. So we create the validator with the legacy receive and our key pair. And Or let's just fill in the missing data, which is we have to sign it with the key pair, and it has to be the source. The sources doesn't matter, I think, because we give it here in the pending info. So we say the pending info is epoch 1. So this is the important part now. So the pending info, which means the information related to the send, the pending info is on epoch 1. So the sender was epoch 1. And we receive it with an account that is on epoch 0. And that should not work. It should fail with unreceivable. Let's see if this test runs. Or let's just let's use a different error code just to make sure that it actually fails, and then we change it back to unreceivable. Okay, there's a failure. Old account info. Oh, that was missing. What's this in here? Account info. Head representative open block balance modified block count and epoch. Oh, I think it uses that epoch here for the decision making. So that means we don't even have to set the sideband. So let's say our old account info is epoch. Yeah, so that data is stored in multiple places, and that's maybe a bit confusing. So that epoch is stored in this BlockSideband, and it is also stored in the account info. The account info is an information struct that exists once per account, and it stores the current epoch, for example. So let's let's just adjust this accordingly. Like that. So I think we can even remove the sideband then. Let's see what's wrong here. Oh, I think I imported something that I shouldn't have. Let's try again. There's a semicolon missing at line 119. Yeah. So the test fails, and it fails with unreceivable, and unreceivable is the correct error code. So now it should be green. Yeah, and let's see if we can even remove the sideband from the test to make it shorter. So let's, can we just comment the sideband stuff out completely? Because I think it just takes the information from the account info. Yeah, that works. So let's delete that host code if it isn't used. So then that means it doesn't have to be mutable. And previous legacy receive. Yeah, looks good. I think this test is too wordy, like too much information in here. I would love to hide all of that irrelevant stuff, because the only relevant information here is that the previous block is, or that our current account is epoch 0. This one, this line here is important. And that the pending info is epoch 1. These two lines are the heart of this unit test. And all of the other lines are noise from my point of view. And I would like to hide that. But not today, because I don't know yet. LFLF says, so the BlockSideband stores the epoch for each transaction in the history separately, yes. While the AccountInfo stores the current epoch for each account, yes. Exactly like that, LF. And the AccountInfo, let's have a look. What does it have? The AccountInfo is, it contains the head block, which is the latest block for this account. It contains the current representative. It contains the open block, which is the first block in this account. It contains the current balance. It contains the timestamp when it was last modified. It contains the total block count for this account. And it contains the current epoch. And every account on the Nano database, in the Nano database, has one account info. And let's just in contrast have a look at the BlockSideband one more time. Which every block has. So every block has a sideband in the database, and the sideband contains the current height of this block, the timestamp when it was added, the successor block, so with the next newer block, the current account number, the balance at the time of this block, and the block details also contain the epoch and information if this block was a send, a receive, or an epoch block, and the source epoch, and this is used if we receive money, if the sender was on, which epoch the sender was on. Yeah, and I think this is a good point now to call it a day. We didn't code much today, but I think it's okay. So we ported a couple of tests, so let me just finish that up. Let's reformat the code. And let's have a look at what we did. Yeah, so these are the tests that we converted to directly test the validator without the ledger, without LMDB stuff. And these are the old tests that we removed. Yeah. Let's add all of that. And let's commit. So we changed the epoch validation tests to not use the ledger. Git push. Yeah, let's call this a day and let's give away the last nanos. So, and if null says, in the end, it's not about quantity but quality here. And sometimes the pace is high and sometimes it's low, and I also like the slower streams. So, but I think we talked a bit about epoch blocks today, and that maybe was interesting. And we talked a bit about how we could make tests more focused and easier to write. So how many nanos did we give away today? Okay, let's see. How many nanos did we give away today? Accounts. This is my account. And if not says, I learned something and had fun. Yeah, cool. I had fun too. So we sent 3 nanos. So we have 2 more nanos to send. Let's just, if anyone wants to join with the giveaway, just quickly post your nano address in chat and you get 1 nano. Maybe you get 1 nano. Okay, so let's go to Google. Do I have it open still? LFLF says, another great stream. Thanks for your answers. And as Andefnal says, continue to focus on quality. Thank you. Okay, yeah. Yeah, I think quality is so important. Like so many projects, software projects, they die because of poor quality. Because this quality, if you don't focus on quality, it just gets messier and messier, and you come to the point where you just can't go forward anymore because you stumble from one bug into the other, and the code is so complex that no one can understand it anymore, and you can't make any big changes anymore. So yeah, I think quality is really important to go fast. Chat, do you know about Robert Martin, Uncle Bob? This guy is a bit controversial, but he has, in my opinion, his books about software architecture and about software quality are really good, and I would recommend them. He definitely changed the way I write code. And he also says, like, you can only go fast if you go well. And there is no trade-off between quality and speed. You have to do it well if you want to go fast. So let's go to Google. I closed it, I think. And let's create a random number between 1 and 5. Ready? Let's go. So 4 again. So 4 was... Where is it? 4 was LF. Congratulations. Copy. And let's go to Nalt, send 1 nano. Oh. Unlock. And let's do another one, because I said I would give away 5 nanos, and that was nano number 4. So let's just do it again. Click the button. And the number is 2. So it is Niush Taula. Let's copy your address and let's send you the 1 nano. Congratulations. Okay, so LFLF says yay. Good. So another stream, and we got a bit of unit testing done. Next stream I will be better prepared, I promise. Or maybe we will work on the tests again. Why not? I think we learned a lot by just looking at the tests. So I hope you had fun, guys. LFLF says, I just love how I receive the nano even before the stream catches up and shows you sending it. Really? Is the lag that big? Yeah. Yeah, nano is so fast. And with all of that securities trouble now in the crypto markets, and the way nano was distributed without gains in mind, like by just giving it away, I think all of that was done really well by Colin and his team, because that just keeps all of that trouble away. Yeah, so let's see what the future brings for nano. And the next stream will be next week, every Tuesday every week, starting at 7:30 UTC. And yeah, so hope you had fun and see you next time. Bye, guys.